Assalamu alaikum everyone. Today we will start solving a set of problems. So we will start with the first problem. In this example, it's written that we should calculate the time to reduce the number of moles by a factor of 10, Na equals to Na0 over 10 in a batch reactor for the above reaction with minus Ra equals to Kca when K is equal to 0.046. So we will write first the assumptions of the batch reactor. We know that the first assumption that there is no inflow and outflow in batch reactor, then it is well mixed, which means that integral of RA dV will be equal to RAV, and there is no inflow or outflow, so FA0 and FA will be equal to 0. So FA0 minus FA plus RA dV will be equal to dNA over dt. So these will be cancelled because they are 0. So the remaining will be RAV equals to, well mixed means that integral of RA dV will be equal to RAV. So RAV will be equal to dNA over dt. So we have two things in batch reactor: the integral form, the differential form, and the integral one. And the integral. So the differential form is RAV equals to dNA over dt. So we will start solving. They said that minus RA is equal to KCA. So we will write this equation: minus RA equals to KCA. And we know that the concentration is equal to the number of moles over volume. So we should put this in our mind. So when solving these kind of problems, so we will substitute Ca with Na over V, and minus Ra will be the same. Then we want RAV to be in a side, so we will multiply each side by V. So this V will go with this, and the remaining will be minus RAV is equal to KNA. We'll proceed with the integral form. So we will write the integral form, which is T equals to integral of dNA over RAV from Na0 to Na. So we know that RAV equals to minus KNA. So we will substitute minus KNA, integral from Na0 to Na. And we know that K is a constant, which is written in the question. K equals to 0.046. So we can take it out of the integral. dNA over Na. Here we remember from calculus 2 that integral of 1 over x dx is equal to ln x. So here also the same thing. So we will be having ln NA from the interval NA naught to NA. Then the upper limit, which is NA, so the upper limit minus the lower limit, so ln NA minus ln NA naught. And also there is a rule which state that ln A minus ln B equals to ln A over B. So we can do it like this: ln NA over NA naught. So now we will continue. We'll just substitute the numbers. K equals to 0.046 and ln NA equals to, they said in the question that NA equals to NA naught over 10. So NA equals to NA naught over 10, which is the same. So 0.1. 1 over 10 will be equal to 0.1. So NA naught, NA equals to NA 0.1 NA naught. So NA naught. So this will go with this. Then we use the calculator to determine the result. So it will be 50.056. This question says that the reaction is to be carried out isothermally, which means that the temperature is constant in a continuous flow reactor. Calculate both the CSTR and PFR reactor volumes necessary to consume 99% of A. And they have given CA equals to 0.01 CA naught, because they said that it will be consumed. 99% of A will be consumed. So when the entering molar flow rate is 5 mol per hour, which is FA naught equals to 5 mol per hour, assuming the reaction rate is RA. The reaction rates minus RA. So we will use this minus RA equals to K, and the K is constant, which equals to 0.05 mol per hour multiplied by dm cube. So if we have a reactor, A, so the input would be 100% FA naught. Then they said in the question that 99% of A will be consumed. FA naught. FA, sorry. FA will be equal to FA naught 1 minus 0.99. So we converted this to 0.99, and this 100 to 1 we divided by 100%. Also this we divided by 100%, so 99. So then we will multiply. FA will be equal to FA naught minus 0.99 FA naught. FA will be equal to, we have here 1 minus 0.99, so it will be 0.01. So 0.01 FA naught. And they said in the question that is continuous flow reactor, which means that CA will be equal to 0.01 CA naught. This is in case they said that continuous flow reactor. I just told you how we got this. Then VCSTR is equal to FA naught minus FA over minus RA. And in the question, it's given that minus RA is equal to K, which is equal to 0.05 here, mole per dm cube. We have minus RA, we have FA naught, but we do not have FA, and we should calculate VCSTR. So how we can do it? I will put the given things here. So we know that the concentration is equal to FA naught over volume, or the volumetric volume. So then it's given that FA naught is equal to 5. FA naught equal to 5 mole per hour So we want FA. FA is equal to CA multiply with the volumetric flow rate, which equals to, CA is equal to 0.01 CA naught with the volumetric volume. And we know that CA naught is equal to FA naught divided by the volumetric volume. So they will go with each other, they will cancel each other. Then we will have FA 0.01 multiplied by 5 is equal to 0.05. So we get FA, so we can proceed. 5 minus 0.05 divided by 0.05 is equal to 99 dm cube. So we got the CSTR volume. Then for the PFR volume, we know that the integral form of PFR is equal to integral dFA over RA, limits from FA naught to FA. So RA is equal to K, minus RA is equal to K. So the positive RA is equal to minus K. So we have this minus RA is equal to K. Then we multiply each side with minus A. So we can determine the new equation. So FA naught to FA dFA over minus K, which is constant, so we can take it out. We can take it out of the integral. FA naught to FA dFA. So the integral of dFA, here it is 1. It is FA. FA from FA naught to FA. Then we will substitute FA, the upper limit, minus the lower one. And we know already that FA, we got FA, which is equal to 0.05. So minus 1, K is 0.05. Then here 0.05 minus 5, I think, which is here. It is written. Will be equal to the 299 dm cube. We finished A. Now we have the second part of the question. The given information is FA naught, which is equal to 5 mole per hour, and FA, which we already calculated, 0.05 mole per hour. Then we have also the new value for K, which is K is equal to 0.001 second. We have a new thing, which is minus RA is equal to K CA. It's given here. For the VCSTR equal to FA naught FA over minus RA, which is equal to FA naught minus FA we have FA naught FA and we do not have CA, so we will just substitute the values, and do not forget writing the units. Here it is 0.0001 second, and here it is written per hour, so we should convert from seconds to hour. From seconds to minutes we multiply with 60, and from minutes to hours we multiply by 60. So 0.001 3600 equals to 0.36 hour, 1/hour. So we just convert this, then we can write it here. Then we do not have CA, but we have this hint, and we know that CA naught is equal to FA naught over the volumetric flow rate. So CA naught is equal to FA naught, which is 5 mole per hour over 10, because it's written here that the volumetric flow rate is 10 dm cube over hour, dm cube over hour. So it will be equal to CA naught is 0.5, then CA is equal to 0.01, which is here, multiply by 0.5, which equals to 0.005. So we can use it here. Then the answer will be 750 dm3. Then we'll proceed with the volume of PFR. The integral form is integral dFA over RA, limits from FA naught to FA, and we know that RA is equal to minus KCA. Sorry. Yes, because it's here in minus, so just multiply each side with the -1. We can take RA out of the, after we substitute RA with minus KCA, we will take it out, the K. The CA is not FA naught to FA, FA over minus KCA, 1 over minus K, over CA. And we know already, we just got CA, which is equal to 0.005. So before we proceed, we know when we do the integral part, the DFA, these things should be the same. So we convert this to FA. How can we do it? CA is equal to FA over the volumetric flow rate, so we will just substitute with this. Because the limits from FA naught to FA, so everything should be in FA term. This can be go. We can also take the volumetric flow rate out of the integral. So ln FA, limits from FA naught to FA, minus 10 over 36 ln FA, the upper limit, minus the lower one, FA is equal to 0.05, this is 5 ln so the answer is 127.9 dm cube. And for the third part, you can try to do it by yourself.